We're going to pick up where we left off in our last tutorial, and this time we're going to talk about how to manipulate the contours that we've got in our drawing now. I'm going to share some of my personal feelings about how this can be done relative to what septic system designers do. If this were for a subdivision, I might handle it a little differently, and I'm going to show you two techniques. One that's relatively easy, and the other will take a little bit of practice. Let's take a close look at some of the strange things we have going on to some of these contours. Let's take a look at. Let's start right here. Here's a small little bump in a contour that I know doesn't exist in the field, and I'll start by saying that generally, when you have your contours doing strange things, it's because more shots needed to be taken in the field. And as I became more experienced, and I was working with a robotic instrument that would collect points very quickly, I would routinely take probably twice as many shots as you would if you were doing it manually with a Stadia rod. I know that sounds a little absurd, but it avoids a lot of editing later, and it really was quite easy to do. So with data collectors today, and especially robotic instruments, there's really no reason to not come back in from the field with all the data you need. But on occasion, you're not going to do that, and clearly when I shot this lot, I didn't get enough data in some places. So let's come back to this little bump in the contour. Let's talk about how contours are generated. If you've ever created a worksheet manually, what you're trying to do is find the even increment between 2 points that represent the contour or the elevation that you want to show. And the computer is going to do exactly the same thing, and it uses interpolation, and you can clearly see that the computer was taking that shot and that shot, and it created a line, and then it divided that line in such a way that it found where the 98 contour passed through that line. Well, it did exactly the same thing for that point and that point. And so we have some strange things going on here. And if we'd had more point data, this might not have plotted just exactly the way we see it here. I know that the terrain didn't do this, so I want to edit that particular bump out. If you click on the polyline, you'll get to see where that polyline changes direction, and you'll see a marker at those points. Well, you can grab them and move them. And so there's one very simple way to edit out these anomalies in your contour lines. Now, depending on where that anomaly shows up, I will choose to do something that simple. If in the area of the future leach field you have an anomaly, you may want to think twice about doing this manual manipulation. I do have some suggestions about how you shoot your topography when you go in the field. In the area of the test pits where the field is actually going to reside, I recommend that you increase the density of your points so that the fill requirements and your elevations are more accurate, and ultimately will reduce cost to the end user of the field, and is really the whole point of your creating the design is to accurately represent the field conditions in that area so that you can do accurate construction later on. Well, there are times when no matter what you do, you're going to get things like this. Now this one here, you can see, is tying, the computer has tied that point to that point, drawn a line, and then divided that line up into increments, and then found the 100, the point where the 100 contour crosses that line. It did exactly the same thing for that point and that point, and hence we have something unusual going on here. Does it reflect what's really going on there? If we had gotten a shot somewhere in between number 48, 52, and 23, maybe some more shots right in this area, would this have smoothed out? Well, this could indicate disturbed terrain. If we had enough shot density in this area, I would say, yep, then it's just disturbed terrain or it reflects reality. But we can see we're a little sparse in this area, and it was a bit disturbed, but it wasn't quite this much. So I know that I should have taken a few more shots. So I'm going to edit those as well. I won't take it all out, but I would remove how exaggerated it is. We have another spot right over here. Same kind of thing going on. When you see multiple contours showing the same feature, you want to be careful because it might be representing some kind of change in the terrain or a swale or something like that. So we do have something going on in this area, but I do know that this again was disturbed terrain because you see one of these shots says top of driveway cut, far side of driveway. I probably should have gotten some toe of cut shots. So I'm going to take some of that exaggeration out. And I feel justified in doing this because the purpose of this particular plan is only to accurately represent in the area of the leach field, or what I call the construction zone, and perhaps the area of the house. And everything away from that area is just a representation. It's I call it flavor, because we're not going to actually do anything with that data. I feel free to do some of these simple edits. And we have some more things going on up here. Again, not enough shot density, especially if there is disturbed terrain. You want to make sure that you do increase your shot density so that you're not dealing with these kind of, gee, did it really look that way? Was it really that way? So those are simple ways to manipulate your contours, which are just polylines, and make it a little more aesthetically pleasing. You can see here we don't have enough shots in this area. We got a little bump in some of these contours. So I smooth them out. It just looks a little more aesthetically pleasing. And if we were plotting like we would in the old days, plotting by hand, we would have smoothed these contours in the same way. This shot is tying to this shot, and when you're tying shots laterally, not perpendicularly to the existing terrain, the contours do some strange things. Because it's just doing math. It's drawing a line connecting them, and then it's dividing that line into increments to find the even contour. And so your contours will come out looking like this. Okay. So that's one way to manipulate contours. And again, outside of my construction zone, I feel justified in doing that. Now I'm going to show you another way, another method that's a bit more complicated and some would say a little more accurate. Alright, now we're going to use a different technique to manipulate our contours, but let's get rid of the ones that are on the screen right now. Let me introduce you to another feature, and it's a special erase command, and again, depending on the version of Carlson you're using, you may or may not have this available to you. But go erase, and we want to erase by layer. Another dialog opens and it says, what do you want to erase? It defaults to all, and I'm just going to take this, I'm going to press this tab that says select the layers from the screen that we want to delete. And you'll notice that the command line is saying select the entities that are going to represent the layers that you want to delete. Well, I want those contours to go away. I want the index contours to go away. And I'll also select the text associated with the contour. When I'm done selecting, I press enter. It brings me back and you'll see it shows you the selection set. If you're happy with that, say OK. And all that information has now disappeared. So we have a clean slate again. Let's quickly draw or shrink wrap our entities. Draw, shrink wrap, take the defaults, select entities, say all. I'm done selecting entities. I'll take the default for reduction, perimeter reduction, create a 2D line, and there it is. Now let's go back into the surface menu, and we're going to select triangulate and contour, and this time on the triangulate tab we're going to say draw triangulation lines. It offers a default layer, which I typically will take. I also want to draw the triangulation faces, and a face is now representing a surface. It has two dimensions. It has an X and a Y. We don't need to draw slope arrows. We'll talk about that later. And we want to write this data, this triangulation data, to what's called a TIN file for triangulation. And it wants to know which format you want to choose. TIN is the preferred, and it says what do you want to call it. Point tutorial. Name it anything you like. It doesn't have to have the same name as your drawing. Save. I'm going to select use my inclusion exclusion areas, and then I haven't changed anything else. Say OK. It's asking us at the command line, select the inclusion perimeter. I select my polyline, enter. Now it says select the exclusion perimeter. We don't have one, so I'm going to say enter. Now it's asking us for our point data. Say all, meaning all the point data inside our inclusion area. Enter. I'm done selecting entities. Press enter one final time, and our topography and a few other things are going to be visible on the screen. There.